Hello everyone, welcome back to the next session on numericals of Bernoulli's theorem. In the previous session I have already discussed about the derivation of Bernoulli's equation from Euler's equation of motion. Now we will see certain numericals on Bernoulli's theorem. Let's start with the first one. Water is flowing through a pipe of 5 centimeter diameter. So the diameter is given as 5 centimeter, which I have converted here into meter. Under a pressure of 29.43 Newton per centimeter square gauge. So the pressure P is given as 29.43 Newton per centimeter square. I have converted into Newton per meter square by multiplying with 10 raised to 4 and with a mean velocity of 2 meters per second. So the velocity v is given as 2 meters per second. Find the total head or total energy per unit weight of the water at a cross section which is 5 meter above the datum line. So the datum head z is given as 5 meter. I am supposed to find the total head. So for solving this, we are going to apply Bernoulli's equation. For total head, the equation is P upon rho g plus V square upon 2g plus z. P term is given, so I have substituted here. Rho, since it is water, rho for water is 1000. G is 9.81. V value is given here as 2, so I substitute. G, you already know it is 9.81. And Z value is also given as 5 meter. So the total head is 35.2038 meter. Here your P upon rho g is called as pressure head, whose unit will be in meter. V square upon 2g is velocity head, whose unit will be meter, and z is the datum head, which is in meter. These terminologies we have already discussed deriving Bernoulli's equation. Let's move to question 2. A pipe through which water is flowing is having diameters 20 centimeter and 10 centimeter at the cross sections 1 and 2 respectively. So as you can see, I have drawn the cross section over here. At section 1, the diameter is d1, which is given as 20 centimeter. I have converted here to meter. And at section 2, the diameter is d2, which is given as 10 centimeter, and I have written as 0.1 meter. The velocity of water at the section 1 is 4 meters per second. So at section 1, the velocity is given as 4 meters per second. Find the velocity head at the section 1 and 2 and also the rate of discharge. So you are supposed to find velocity head, which is v1 square upon 2g, and velocity head at section 2 will be v2 square upon 2g. And rate of discharge is given by capital Q. So how do we solve? The velocity head directly formula you can use v1 square upon 2g. V1 is given as 4 meters per second. So here I substitute 4 square upon 2 into 9.81. So I get the answer directly. Velocity head at section 2, the formula will be V2 square upon 2g. Now since V2 is not given directly, so what I'll do is I'm going to use Q is equal to A1 V1 is equal to A2 V2. Now either you can use Q equal to A1 V1, either you can use Q is equal to A2 V2, or you can use A1 V1 is equal to A2 V2. These are the two ways of solving. Now since Q is also not known to me, I will use A1 V1 is equal to A2 V2, which is continuity equation. So I will get the answer of V2 directly, which is 16 meters per second, as I know other values. So I can calculate V2 square upon 2g is 83.047 meter. For calculating rate of discharge Q, the formula can be either Q is equal to A1 V1, or I can write down Q is equal to A2 V2. I am using A1 V1 here. Just substitute pi by 4 d1 square into V1. You will get the answer of Q in meter cube per second. For converting meter cube per second into liters per second, you need to multiply with 10 raised to 3. So this is the answer in liters per second. Let's take up another numerical. Water is flowing through a pipe having diameters 20 centimeter and 10 centimeter at section 1 and 2 respectively. So at section 1, my diameter is 20 centimeter. At section 2, my diameter is 10 centimeter. The rate of flow through the pipe is 35 liters per second. So you can write down Q is 35 liters per second. When you convert into meter cube per second, you will have to multiply with 10 raised to minus 3. The section 1 is 6 meter above the datum. So from the reference line, your height at which your section 1 is lying is 6 meter. So I write down Z1, which is the datum head at section 1, is 6 meter. And section 2 is 4 meter above the datum, so Z2 is 4 meter. If the pressure at section 1 is 39.24 Newton per centimeter square, so P1 is given to me, I can convert into Newton per meter square. Find the intensity of pressure at the section 2. So you are supposed to find P2. Now how do we solve? We know Q is equal to A1 V1. Since I know the diameter D1, I can calculate area as pi by 4 D1 square. Q value is directly known to me, so if I substitute in this formula, I'll get the value of V1. I also know Q is equal to A2 V2, so V2 is again Q upon A2. If I substitute, I'll get the answer for Q. Now I have drawn a small figure over here as far as the data is concerned. Using that, this diagram can be made. Now if I apply Bernoulli's equation at sections 1 and 2, we will get P1 upon rho g plus V1 square upon 2g plus Z1 is equal to P2 upon rho g plus V2 square upon 2g plus Z2. Since all the data is known except P2, I can substitute the values and get the answer for P2. Initially you will get the answer in Newton per meter square because all the quantities are in Newton and meter. You can convert it into Newton per centimeter square because P1 was originally given in the question in terms of Newton per centimeter square. Even if you don't convert, it's absolutely alright. Now we'll move on to the fourth numerical. Water is flowing through a pipe having diameter 300 mm and 200 mm at the bottom and upper end respectively. The intensity of pressure at the bottom end is 24.525 Newton per centimeter square and the pressure at the upper end is 9.81 Newton per centimeter square. Determine the difference in datum head if the rate of flow through the pipe is 40 liters per second. Now as far as the data is given, I have drawn this diagram. This is my datum line. The bottom edge has a diameter of 300 mm and the upper edge has a diameter of 200 mm as given in the question. The bottom edge has a pressure of 24.525 and upper edge has a pressure of 9.81. So everything is written here. At section 1, which is the bottom edge, diameter and pressure is mentioned. At section 2, which is the upper end, diameter and pressure is mentioned. I have converted over here each unit into meters. You can see this was in mm, I have converted into meter, and this was in Newton per centimeter square. Again I brought it into meter. So we have brought into a single unit system. And the rate of flow is given as 40 liters per second, which again is 0.04 meter cube per second. You are supposed to find difference in the datum head. So I have written over here Z2, which is the higher level, minus Z1 is what we are supposed to find. Now you know Q is equal to A1 V1. So you can calculate V1 Q upon A1, substitute, get the answer. Q is equal to A2 V2. Known the value of Q and A2, you can get the value of V2. If I apply Bernoulli's equation between section 1 and 2, the equation is P1 upon rho g plus V1 square upon 2g plus Z1 is equal to P2 upon rho g plus V2 square upon 2g plus Z2. Here, all the values are known except Z1 and Z2. Now, if you get the difference over here, it will be 13.7 meter.